Hello and welcome to Chapter 6. Chapter 6 is all about signed numbers. Signed numbers are negative numbers, things less than 0. If we take a look at a number line, we'll start here at 0 and count our way up. 1, 2, 3 for our normal whole numbers. And then we'll count down 3, 2, 1, 0. What comes before 0 is a negative 1. We keep going down, -2, -3, and we can go all the way down, just like we can go all the way up with our positive numbers, 1, 2, 3, 4, on up to infinity. We can go down with our negative numbers, -1, -2, -3, on down to negative infinity. Some uses for negative numbers: say you are outside and the temperature has dropped below 0 degrees Fahrenheit. Right, you're down here in the -5 degrees Fahrenheit. That's one example of a time you would use a negative number. Or say you're swimming below the sea level. So as you're swimming along below the sea level, right, the farther you are below the sea level, the more negative your height is. So for example, if I'm now down here, I could be at -30 feet below the sea level, whereas if I swim up to the top, I may only be at -10 feet. Let's go ahead and add some signed numbers. We all know adding positive numbers, so for example 4 plus 3 we can get 7, but if we're adding negative numbers, a -4 plus a -3, right, we should get a -7, doing the same operation on the other side of the number line. So if I take a look at my number line here, if I start here at 0, right, and I want to go to -4, that's going to the left -4. So I went from 0 down to -4, adding -3 to it. I'm going to be going in that same direction another 3 places. So going another 1, 2, 3 places, I end up here at -7. So anytime you are adding things with a same sign, so for example 4 plus a +3, you'll add it just like you normally do to get 7. A -4 plus a -3, you can add this right the same way you would with the positive numbers, and just remember that your answer will be negative. So again, adding things of the same sign, you add them together and keep the sign that your numbers had while you were adding. So for the negative numbers, -4, -3, add your 4 and your 3, right? And just remember that they were negative, so your answer is negative. So same sign, add them together, and keep the sign. If you're adding things of a different sign, say 4 plus a -3, here you're going to subtract. If we take a look at that on the number line, starting here at 0, I go up to my 4. So starting at 0, I go up to 4, and then adding -3. Right? Again, I'm going to be going now in the left direction, 3, and that brings me down to +1. So 4 plus a -3 is equal to 1. What we can learn from this is that adding a negative number is the same thing as subtracting that number. So 4 plus a -3 is the same as 4 minus 3, right? Again, giving us 1. If instead I have, say, a -4 plus 3, here again doing the same thing on my number line, starting at 0 and going down to -4. So I go down to -4 on the number line, and then adding 3, I'm going to go now in the right, in the positive direction, 3. And this leaves me now at -1. One thing that might help us learn a little trick on how to remember adding and subtracting numbers with different signs, right? We can learn a little bit more about absolute value. So absolute value, putting anything between two straight lines there, for example the number -7, the absolute value of -7 is a +7. What absolute value does is it just takes the distance from 0 that that number is. So counting down to -7, I have to move 7 places to the left. Basically, what absolute value does is it makes any number positive. So if I have the absolute value of 4, that gives me a positive 4. Absolute value of a -2, you guessed it, a positive 2. So absolute value of any number just makes it positive. If it's already a positive number, it just stays positive. The way we can apply this idea to our addition of positive and negative numbers is that anytime we have numbers with different signs that we're adding together, so for example that positive 4 plus a -3, we can always take the number with the largest absolute value, the 4, and subtract from it the one with the smaller absolute value, 3, right? And that gave us 1. Now we keep the sign of the number with the larger absolute value. Okay, the same thing applies down here, -4 plus 3. -4 has a larger absolute value of 4, so we can take 4 minus 3, right, and that gives us 1. But the 4 had the negative sign, so our answer has to be negative. Again, the idea here is adding numbers with different signs, a negative and a positive. Anytime you have that, you can subtract those two numbers, the number with the larger absolute value minus the smaller. Right? That's a little easier to think about than -4 plus 3. It's a little easier to think of it as 4 minus 3. Right? And then we just have to remember in the end, our answer was negative because that larger absolute value was a negative number, so our answer is going to be negative. We can try this again with, say, -6 plus 4, something like this. Right? Our larger absolute value is 6, our smaller is 4, so 6 minus 4 gives me 2, but the 6 had a negative sign, so my answer is negative. Also, if I had, say, 15 plus a -13, right? Larger absolute value is 15, so 15 minus 13 gives me 2, and that larger absolute value was positive, so my answer is positive. If I have -15 plus a -8, okay, here they both have the same sign, so I'm just adding those two numbers together, 15 plus 8, which gives me 23, and they're both negative numbers, so that's negative for my answer. So again, numbers with the same sign, you add them together and keep the sign. Numbers of different signs, you subtract the smaller absolute value from the larger absolute value and then keep the sign of the larger absolute value. Let's take a look at some more negative signs. Let's say I have the number 3. If I want the opposite of that number, I throw a negative in front of it. The opposite of 3 is a -3, whereas the opposite of -3 is a +3. However, I can do the same thing to this -3 to make it a +3, right? So I can throw another negative sign in front of it. Anytime I throw a negative, I'm asking for the opposite of that original number. So 3, throw negative, I get -3, throw another negative in front, it should give me +3, and indeed it does. What we learn from this, right, is that anytime you have a negative right next to another negative sign, that makes it positive. A negative and a negative cancel out to give me a +3. So anytime you have this, again, it's positive, and we can just rewrite it as that +3. So if I have 4 minus a -3, I can rewrite this problem as 4 plus 3 and then carry out the math like normal. But then if I have -9 minus 7? Well, we already saw last time that subtracting a number was the same as adding its negative. This is the same as -9 plus a -7. So again, here we see that they have the same sign. They're both negative. So we can add those two numbers together, which gives us 16. And then we keep the sign that they both had, negative 16. Okay, both cases give us the same answer. So if I have 3 minus 7, okay, again, that's the same thing as 3 plus a negative 7. So I have here again two numbers with different signs, so I subtract the smaller absolute value from the larger absolute value. So I have 7 minus 3, which gives me 4, and then the 7, the larger absolute value, had the negative sign, so my answer is negative. In both cases, negative 4 is my answer. So let's throw it all together in one problem. Okay, we see here that we have a double negative, so we can rewrite this as 2 plus 6. Right, minus 10 is just minus 10 plus 4, and then plus a negative number. Well, we can either write this as plus negative 11, or we can write it as minus 11. Again, they both mean the same thing. So again, I'm just going to add these together from left to right. 2 plus 6 gives me 8, minus 10, right, plus 4 minus 11. So 8 minus 10 gives me negative 2, plus that 4 minus 11. Negative 2 plus 4 gives me positive 2 minus 11. And 2 minus 11 gives me a negative 9. And that is my final answer. Let's take a look at some multiplication. If I have 5 times 3, right, what that is saying is I have 5 3 times. 5 plus 5 plus 5. Right, giving me a total of 15. Alright, multiplication is just repeated addition. So instead, let's say I had negative 5 times 3. This is just saying I have negative 5 3 times. Negative 5 plus a negative 5 plus one more negative 5. Okay, if I add these three together, I get a negative 15. So what we can see here is multiplying a negative times a positive, my answer will be negative. So let's take a look at the rules for multiplying signed numbers. Anytime you have the same sign, positive 5 times 3 or negative 5 times a negative 3, you will get a positive answer, 15. So same sign, positive answer. When you have an opposite sign, negative 5 times 3 or 5 times a negative 3, that gives you a negative answer. So negative times a positive or positive times a negative, both give you negative answers. And that's our rules for multiplying signed numbers. So negative 4 times 7, they have different signs. So negative times a positive gives me negative, and then 4 times 7 is 28. So negative 3 times a negative 9, same sign, positive answer, and 3 times 9 is just 27. Let's say I take negative 2 times negative 2 times negative 2. So negative times a negative times a negative. Well, I just take this one piece at a time. Negative times negative gives me positive, and 2 times 2 is 4. So I have the positive 4, and I still have to multiply that by one more, negative 2. 4 times a negative 2, okay, it's a positive times a negative now, which gives me a negative answer of 8. A negative 8. When it comes to dividing with negative numbers, the same rules apply as with multiplication. If I have 8 divided by 2, right, it's positive and positive, my answer is positive. If I have a negative 8 divided by a negative 2, same sign, so again my answer is positive, and I just divide like normal. 8 divided by 2, 4. When they have opposite signs, like negative 8 divided by 2 or 8 divided by negative 2, okay, these, again, opposite signs give me negative answers, and then I just divide like normal. 8 divided by 2, 4, so I get a negative 4. Same thing here, again, negative 4. Opposite signs, negative answer. Same signs, positive answer. Same rules as apply with multiplication. Now let's take a look at some use with exponents. So an exponent, when I'm dealing with an exponent, I have a base and a power. So for example here, 2 is my base, 4 is my power, or my exponent, can call it either one. And what this is saying, 2 to the 4th power is just 2 times itself 4 times. So 2 to the 4th power, 2 times 2 times 2 times 2. Alright, which gives me 16. So if I had, say, 3 times 3 times 3 times 3 times 3, if I want to write that with exponential notation, right, it's 3 times itself 5 times, so my base is 3, my exponent or my power is 5. And if I evaluate this, if I actually work out the math, 3 to the 5th power is 243. So again, if you have 3 times itself 5 times, writing in exponential notation gives you 3 to the 5th, evaluating it gives you 243. So if we take a look at some more exponents, say 2 to the 4th power, 2 to the 4th power is 16, it's 2 times itself 4 times. If I have, say, negative 2 though, times the 4th power, that's saying negative 2 times negative 2 times negative 2 times negative 2. Again, negative 2 times itself 4 times. A negative times a negative is a positive. That positive times a negative is a negative. And that negative times a negative is a positive. So, because there are an even number of negative signs, I have a positive answer of 16. So that negative 2 to the 4th power gives me a positive 16. A negative number to any even power gives me a positive answer. So take a look though, if I write it like negative 2 to the 4th power without parentheses. This is the only time that I do not automatically associate that negative sign with the number that comes right after it. Here, this is 2 to the 4th power, and it's being made negative. Here, just the 2 is being raised to the 4th power. So this is negative 2 times 2 times 2 times 2, or negative 16. So anytime I do not have parentheses, I'm just raising the number to the power. Right? If I have that negative out in front, my answer will always be negative. A negative 2 to the 2nd power, again, that's going to be negative 2 squared of 4. If I were to include the parentheses, negative 2 squared, okay, now it's taking that negative 2 squared, so negative times the negative, giving me a positive 4. So to wrap that up, any negative in parentheses to a even power gives me a positive answer. Any negative number squared without parentheses is always going to be negative, regardless of what the power is. So now if I want to combine everything we've learned so far today, we need to understand order of operations. The first thing we always do is parentheses. So anything inside parentheses gets done first. Second, exponents. Exponents, so next I do whatever has an exponent, like 2 cubed. Right, I do all of those second. Third, I multiply and divide. So if I have 3 times 4 divided by 2, okay, I multiply and divide both of those in the same step, going from left to right. So 3 times 4 first, and then divide by the 2. Fourth, I add and subtract. So this, right, 3 plus 4 minus 2, something like this. Again, I would want to add and subtract all of these in the same step. Now this, it doesn't really matter if I go from left to right. I could take 4 minus 2 first, and then add it to 3, or 3 plus 4, and then subtract 2. Adding and subtracting doesn't really matter which order you add these numbers in. Multiplying and dividing, it does matter, right? Always go from left to right. exponents, do all your exponents together, and then parentheses. So parentheses first, then exponents, then multiply and divide in the same step, and then add and subtract in the same step. These are our order of operations. So if I have this problem here, right, I want to follow the order of operations to work it out. The first thing I'll check for are parentheses, which there are none. So I can go on to the second step, exponents. I have one exponent, the 3 squared, and I'll work that out first, but I'll bring everything else down just like it's written. So 3 squared, 9. Now the exponents are taken care of. I go on to the next step, multiply and divide. There's only one division problem here, so I'll do that next. Can I bring my 12 down since that's not being used yet? 54 divided by 9 gives me 6. Now I have one thing left, addition. It's the last thing I have here in my order of operations, so I have 18 now as my final answer. One more thing we can talk about are square roots. So square roots are associated with squares. So for example, taking a look at 3 squared, that gives me 9. The square root, this is the square root symbol. Right? If I ask for the square root of 9, I'm asking what number was squared in order to get that 9. In this case, 3. When I'm taking square roots, I'm always looking for the principal square root or the positive square root. Right? It is true that negative 3 squared also gives me 9, but when I'm asking for the square root of 9, I'm just going to give the positive answer, the positive 3 in this case. So other square roots, right? The square root of 16 would be 4, the square root of 100 would be 10, the square root of 81 is 9. There are an infinite number of perfect squares, right? These are called perfect squares because their square root is a whole number. Right? Not everything is a perfect square. For example, the square root of 5.74, right? This is not a perfect square. Right? It does fall somewhere in between the square root of 4, which we know to be 2, and the square root of 9, which was 3. So this answer should be somewhere between 2 and 3, right? And it is about 2.40 if you go ahead and plug that square root into your calculator. So if we take a look back at our order of operations, we need to add in roots somewhere in here, and roots will go here, right with our exponents. So exponents and roots will be done in the same step. However, we should take note of how to work out this 9 plus 16 inside of our square root. Anything under square root needs to be worked out first. So for example, the way to do this would be to add 9 plus 16 to get our 25 first, and then we take the square root, 5. Okay, it is not the same as if we split this up, the square root of 9 plus the square root of 16. That would give us 3 plus 4, or 7. This is the correct way to do it. This is not. Okay, so when we're working out roots, basically we can treat whatever's inside the root as having parentheses around it, and then we work out what's under the square root first. One other thing we should look at is if we have, say, 4 squared times the square root of 36 minus 15 all over 3. When we go to work this out, even though this is a division problem, all of this being divided by 3, we're going to treat, right, our numerator here as having parentheses around it and our denominator as having parentheses around it. Anytime we have a problem set up like this as one giant fraction, we want to work out everything up top together first, everything on the bottom together first, and then at the very end we will divide. So let's go ahead and follow our order of operations for our numerator here and our denominator. So up top, right, we're going to do exponents and roots first. So 4 squared and the square root of 36. That gives me 16 times 6 minus 15. That's all over here. We just have 3, so we'll bring down that 3. Next, right, there are no more exponents or roots, so we will multiply and divide. Right here, multiplication is our next step. We're not going to do that division again until the very end. So 16 times 6 gives me 96, minus that 15 over 3. Now I do my subtraction here. 96 minus 15 gives me 81 over 3. And 81 divided by 3 is 27. And that is my final answer. Again, I waited to do that division until the very end just because of how this problem was set up, right? Again, as a fraction. Alright, that is it for Chapter 6. Make sure to bring your Chapter 6 homework into class. We will also be working on a couple word problems to make this a little more interesting. And we will again always end with that quiz over Chapter 6. So be sure to bring whatever questions you have from this video, and we'll start with that in our next class. I'll see you then.